This is section 8.4. We're going to be talking about annuities, stocks, and bonds. An annuity is a sequence of equal payments made at equal time periods. So let's say, for example, you're going to pay $100 a month into a savings account. That would be an annuity. The value of an annuity is the sum of all deposits plus any interest that's been paid to this account. So let's say, for example, you deposit $1,000 into a savings plan at the end of each year for 3 years. The interest rate is 8% per year, compounded annually, and find the value of the annuity after 3 years. So here's what's happening, okay? At the end of the first year, you deposit $1,000. Okay? Well, you don't get any interest on that because the $1,000 hasn't been in the bank for a year. So right now the value after the first year is $1,000. Now at the end of the second year, you're going to be getting interest on the $1,000 that's been in your account for the past year. So 8% compounded once per year and for 1 year. Okay, so if you calculate that, that will tell you how much is in your account from the previous $1,000, but remember at the end of the second year you're going to be depositing another $1,000. We can continue to do this at the end of the third year. We would have the interest. We would have the interest from the amount that's previously in there plus another $1,000. With actual numbers here, this is the initial $1,000 that we deposit at the end of the first year. At the end of the second year, this will give us the amount plus the interest from the first year plus the $1,000 we deposit at the end of the second year. So altogether, right now, at the end of the second year, we have $2,080. And then at the end of the third year, we have the $2,080 plus interest. So that's this right here. Plus, we're depositing another $1,000. We're depositing another $1,000. So we end up at the end of the third year with $3,246.40. Now, to figure out how much interest you earn, you first have to figure out how much you actually deposited. Okay? So, you deposited $1,000 at the end of the first year. You deposited $1,000 at the end of the second year. And you deposited $1,000 at the end of the third year. So altogether, you deposited $3,000. But you have $3,200 in the bank. So what the bank gave you was the difference between those two numbers. So the bank gave you an interest $246. Now, you could use this method to figure out after the end of the third year, the end of the fifth year, the end of the 20th year, but that's pretty long and involved process. There is actually a formula that does the exact same thing. The formula is pretty complicated, but it's faster than figuring out the end of the first year, the end of the second year, the end of the third year. Okay? So when you're putting this stuff in your calculator, remember you work from the inside parentheses out. So inside the parentheses, and remember the top is going to be grouped separately from the bottom. So inside the inside parentheses, you have a plus and a divide. So you divide first, then you add. So right now, you've got a number here, okay? And you've got a power. So you're going to take this number here that you kept in your calculator, do not round, raise it to this power, find an answer, and subtract 1. You're going to keep this number in your calculator, and then you're going to multiply by p. At this point, it's pretty tough to get the numerator divided by the denominator without writing the number down with as many decimal places as possible. Do not round at this point. So you're going to write this number down on a piece of paper, piece of scratch paper. You're going to calculate this number, and then finally take the top divided by the bottom. Yes, it sounds complicated, but trust me, it takes a whole lot less time than the first method I showed you. To save for retirement, you decide to deposit $1,000 into an IRA at the end of each year for the next 30 years. If you can count on an interest rate of 10%, which you can't because nobody pays 10% per year compounded annually, how much will you have from the IRA after 30 years, and how much of that will be interest? All right, so we are going to use this formula here. Now, P is the principal, it's the payment. It's what we're putting into the account each year. So we're depositing $1,000. The interest rate was 10%. And we decided it was compounded annually. Remember, compounded annually? N is the number of times it's compounded per year. Annually, it's compounded once per year. That's annual, means once per year. Okay, so we have n is equal to 1. 1 times the number of years. T is always, 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 always in years. We're going to leave it in the account for 30 years. And all of this divided by my interest rate of 10% over n is equal to 1. So, once again, you're going to take 10% or 0.10 divided by 1. Then add 1. Then raise it to the 30th power. Then subtract 1. Then multiply by 1,000. Write that number down with as many decimal places as your calculator will give you. Take 10% divided by 1, or 0.1 divided by 1. And finally, take the number you just wrote down divided by the denominator, 0.1 divided by 1. And dun-ta-da, it will give you 164,494. Okay, so in your IRA, after 30 years, that's how much money you have in the bank. Okay. Now the question is, how much did you yourself actually deposit? Because anything that's extra would be interest. So be careful when you're calculating how much you deposit. For some reason, students get that wrong every time. You deposited $1,000 at the end of the first year, the second year, the third year. You did this for 30 years. So if you deposited $1,000 every year for 30 years, you yourself deposited $30,000, 30 times 1,000. So this is the amount that you yourself put into the account. But this is how much you have. So to figure out how much the bank gave you, remember the 30,000 is how much you contributed, and the 164, that's how much you have in the bank. So the difference between these two, the bank gave you in interest 134,494. At age 25, to save for retirement, you decide to deposit $200 into an IRA. IRA stands for Individual Retirement Account. So whenever somebody says IRA, it's retirement account. At the end of each month, interest rate is 7.5%, compounded monthly. Okay? How much will you have when you retire at age 65? Well, we didn't come right out and say it's X amount of years, but if you notice, you're 65 when you retire, you're 25 when you start, you've been depositing money for 40 years. So T is going to equal 40. It's compounded monthly, so N, remember, is the number of times per year. Monthly, there's 12 months in a year. N is equal to 12. Be careful when you change the decimal or this percent into a decimal, because you got to move the decimal 2 places. 0.075 will be your interest rate, R. So let's plug these numbers in. 200, how much you put in each month. Your interest rate, N is equal to 12. It's compounded monthly. And we had it in there for 40 years. All right, so calculate. Remember, start here, you add the 1, you take it to the power, you subtract 1, multiply by 200, leave that number written down somewhere with as many decimals as possible, divide the bottom, and finally you have 604,765. All right. So that's how much you have in your account. The question is, how much interest did the bank give you? This is where you have to be careful. Everyone gets that if you put $1,000 a year in for 30 years, you yourself deposited 30,000. But for some reason, when you deposit $200 a month, every month, every year for 40 years, somehow or another, when students calculate how much you yourself deposit, they either forget every month or they forget every year. And I'm not sure why. So they deposit $200 12 times a year for 40 years. 200 times 12 times 40. That will give you 96,000 is how much you yourself actually put into the account. The account balance is 604,000, so if you subtract the two in interest, you have approximately 500,000. So the bank actually gave you 500,000, you yourself deposited 100,000. So not a bad deal. All right, this is the same formula, it's just been solved for P. This is when you know how much you have to save for. You're saving for a specific amount of money. You know that you want to buy a car for $10,000. How much do you have to deposit each month? You know that your college education is going to cost $100,000. So how much do you have to save each month? Okay. So it's the same formula, it's just solve for a different variable. You would like to have $20,000 to use it as a down payment for a home in 5 years. You're making regular end of the month deposits. That's with the annuity. That's what an annuity is, where you make regular deposits that pay 8% compounded monthly. So 8% compounded monthly, N is equal to 12. That's the number of times per year. R is equal to 0.08. And we're putting it in for 5 years, so time is equal to 5. And we need to have $20,000, but we need to have it in 5 years. So A is 20,000. So you plug the numbers in, 20,000. Interest rate was, I think it was 8%. Was it 8%? It was. Compounded monthly. Interest rate is 8%, compounded monthly, and is equal to 12. We're going to put it in, remember we're putting it in for 5 years. Okay, same idea. You're going to do the top separate from the bottom. Leave as much in your calculator as possible. Again, you start inside the parentheses, do the 0.08 divided by 12, then add 1, then raise it to the power, then subtract 1. Write that number down with as many decimal places as possible. Take 0.08 divided by 12, then multiply by 20,000. Write that number down with as many decimal places as possible, and finally divide the top and the bottom. And when you do that, you get 273, or approximately 273. It's been rounded. So that tells you that you should deposit $273 every month, so that at the end of 5 years, you will have $20,000 that you can use as the down payment on a home. Now, to figure out how much you end up depositing and how much you ended up with interest, you're paying $273 a month. Every month means 12 times, every year for 5 years. So don't forget, you got to multiply by 12, you got to multiply by 5. So you end up yourself depositing $16,000, but you have $20,000 in your bank account. So to figure out the interest, you subtract those two, and the bank gave you $3,600 for interest. All right, I'm going to stop here for the end of part 1. I will take this up again for part 2.